How's it going? I just woke up. So I'm going back to this program and I'm trying to insert this root node thing, and I'm confused as always by all these seeks with different hard-coded numbers. Yeah, I think that's 4. And then, yeah, we minus 2, copy f to t, copy f to x. And then that's got to be 4. Wait. Copy f to t, seek to the beginning, copy f to x. I think this was wrong before. 1, 2, 3, 4, 5. Well, now it's 5. Fuck it. And this one, seek to the beginning. We seek t. 1, 2, 3. Dude, it's so confusing. Okay, let's just see if we got that. So it should be the 3rd slot. Okay, this is all messed up. All messed up. These are all getting 0. Oh, we're not trying to put a number in the 0 yet. Let me put like minus 7 there just so we can see. Okay, well that crashes it real bad. Oh, stop at traverse. Okay, minus 7. Like our second entry is getting garbled. But that's the only one. 31. We need to be 6 instead of 5. Traverse. Okay. Oh, no, still. Why is the second one wrong? What do we do? We go here. Okay. Copy this into X. So we've put 7 into the top, which is right. We seek to the end. Put X in the file. That's right. Okay. This looks correct so far. Whoa. That's the problem. This is not supposed to fire. Okay, this isn't right. This is supposed to be our index, not our parent index. Oh, because when we did T1F, oh no, okay. We changed this last night as a little optimization. It's not the same. We need this value to be in T. Copy F to T. Here we can do this. We can go add F6T. That's all, or add I. All right. Let's try this again. Boom. Hey, look, it's all... No, it's the third one is hosed now. What? 1, 2, 3, 4, 5. The hell? Wait, what? 1? There should be a 6 number here. That should be 0. Dude, I messed things up so bad. Okay, let's go there. So, okay, there's 5 numbers and the thing, and the last number is 0, which it should be. The second to last, or whatever, last minus 2 and last should both be 0. That's great. So we get the next entry. Okay, T is 7. We jump to the end of the file. We write out our record. Great. We're inserting this node into the tree. We seek 2, copy the link. It is null. We copy this into T, that's correct. We go to the beginning, we grab this number, that's correct. We seek 3, then we're back at the link. Oh no! Seek 2. What? Okay. How did I mess that up? Okay. So now we're putting our left link correctly. Let's just see how that goes. We probably, oh my God. We probably messed up the right link as well. Maybe I shouldn't have added one. Okay, right node. We seek 4, that's the link. Good. We copy that. We get the offset. We go to the beginning. We get that. We go ahead. These shouldn't have been incremented for some reason. All right. Hey, look, we've got a full thing. We've got a full thing. We've got -7s in our placeholder slots. We've got valid offsets. These should also be multiple of 6 plus 1, which they are. So this is all well formed. This is good. Now the question is, before we do the tree part, do I try to do this other optimization that I thought about? And the answer is, do we run out of instructions? We're not out yet, so let's not do it. Let's try to make it work. So now our goal is to fill in that -7 when we link with the value from the parent. Okay, so this whole write it thing where we just were, we need to put a parent link in that slot. And we might run out of instructions because we might need to do it here. So when we seek T, we're going forward into the records. Okay, so we seek to the end of the file because the thing that we just inserted into the tree is this guy at here. And then we go 1, -1, 2, 3, 4, minus 4 to get to the 7 there, the -7. This is going to be easier than I thought. We seek -4, copy T to F. Maybe that does it. Maybe that does it. Let's see. Okay, we're going to have to put 0 here instead of -7. And all of these should be a multiple of 6 plus 1 that is different from the node's offset. Oh, wait. Second value. So parent 1. That makes sense. Left child, right child. Parent 13, parent 7, 19. This all looks good. So now let's make that -7 be 0. And I think now we're ready to use this information, which hopefully we can do in 2 instructions. God. Okay. So we go to the right link. We go back to the parent. This should be seek -3. Wait, we stomped the wrong place. Okay, these seeks are not correct because we didn't edit them before. Okay, so this one has to be getting the left link, which it isn't. This has to be seek 3. We null out that link. Okay. To check the right link, we seek 2. That's correct because this is a relative offset. That's what happened before, is they were relative offsets, but to some, I don't know. Anyway, we fixed it. We null out the right link. And it's not there. So we go back to parent. This should be -4. for some reason. Okay. I don't know. Okay, so we are here. We're there. We're reading that link. We're going back to the parent. Okay, we're reading his left child. Oh, output needs to go -4. Go back to parent. Wait, what? Because we were already off one from the previous output is what happened. All right. We go here. We go there. We jump output. Why is that 3? This thing about X being current node is not necessary. Oh, because 3 is the left link. Wait, what is going on? Okay. We seek T. We seek 3. This is the left link. Okay. Seven. We jump. We seek T. We seek 3. This is the left link. To go from, this is definitely supposed to be -4. Because we do it after we've read the left link. I don't know. Okay. Every time we get here, we should be on a name. Name. Not on a name. What the hell? See how this should always be name, number, name, number. It's screwed up right there. This should be the only jump to output. So how, this should always be beginning of the file plus T plus 3. Let's just see what T is. First time, T is 1. That's great. So we go to output. Oh, well, we don't jump there. Okay, here we should be on a name. 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 This is wrong. This is wrong. Okay. So anytime before we get to recurse, we have to make sure T has the right number. So how about that? My code's too long. There. Well, this is already wrong. What the hell? I put it, there we go. I was grabbing the negative number. There we go. There we go. All right, what have we got? We've got our file. It's only got 6 entries, which is not enough. And there are duplicate entries, which is not good. Aside from that, everything's great. Okay. Tree traversal. We step. We go to the left node. Okay. 149929. We seek. Yeah, we seek 3. It's the left link. We copy F to T. We F jump output. We seek -4. Copy, copy. This is correct so far. We navigated the left links and we're at the lowest value. O2 whatever is clearly the lowest value. So we copy both of those onto the network. We're seeking ahead 2 to check the right link. That's not correct. Damn! Which means this is wrong also. We got to seek 3 here. Okay. All right. Okay. So now we have too many entries. We're getting there. First we have too few, now we have too many. The first problem is in our 4th output. We're visiting a node. Yeah, so we're printing things twice. We're printing things when the left is null, and we're printing things when the right is null. And that's not correct. This is difficult because I need more instructions to deal with this. So after we do the right value on the tree, we want to go up to the parent until we find someone whose right node is not 0. Okay, however, which will save us 2 instructions. Because we were only doing that. Yeah, let's try that. So So first of all, yeah. So we seek through, we copy F to T. We don't actually need to do this. What happened? My keyboard came unplugged. The plug is very loose. Okay. So we want to go up. Is going up 2 levels of parent sufficient? Like, there? Wait, I'm not convinced that this matters. Let's see. Okay. Nope, we're infinite looping. Okay. Does matter. Does matter. Let's just see what entertaining file we get out of that. Yeah. Okay, I mean, like we could, okay. We could spend 2 instructions. I really want to get to the point where this is working. We could spend 2 instructions to wipe this after we send it, like put a 0 in there, and then there's going to be several instructions. Whoops. Several instructions that we don't have space for. But to get that space, now we can go attack this part of the program, because I realized we're like doing more than we need to in this guy to synchronize the transmission. So this guy launches a reporter. That reporter does all this network communication just to talk back to this guy, and this guy does all this stuff. It's not necessary. So here instead, so all this probe has to do really is copy nerve to M and halt. So we could save 3 instructions here, and then we don't need to void these. All right, so, but maybe we spend 1 to go mode. So let's say we need to spend 2 to go mode. Oh, this sucks. Unless we put that there. Let's see. So if we have an MRD, we copy, we go mode, we copy M to X, which will also kill. Go mode, copy X to M, copy. We might as well just kill and go host M. It'll be more readable. So here we're in global mode. Right? Yes, global mode. So that means that when we jump to all done, we don't need to be in global mode. Or we don't need to switch modes. But when we go to a new room, then this mode needs to be here to go to local mode. But that's okay because we can get rid of this one. Let's see. That totally didn't work. All right. Global. Up. Second time we go into a new room. What is going on? Okay, wait. My reporter is not dying off, first of all. So the reporter guy, I just said we do this and then we halt, and then I didn't delete all the instructions. You don't really need a halt here. I'm going to do it just for safety. So under what conditions do we jump to new room? There. That's it. So we should be in global mode every... Why are we at all done already? Oh, because if we have no MRD... Dang it! We're in a different mode here if we have MRD versus not. Okay, fine. This is bad. This is very bad. I need to insert 2 instructions to fix this. And then I can remove this halt, but there's got to be a better way to do it. Okay, we switch mode to global, no matter what. Oh, maybe it's fine. I don't know. It's not fine. Okay, wait. We should be in global always when we go here. We're not. The first time we're not. What am I doing? Okay, hold on. Local mode at the beginning. We need an even number of mode switches all the time. So remode, remode. Why am I... Is there any other mode here? Okay, local mode, local, 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 local. Why is it working all of a sudden? Looks like it's working fine. Am I on drugs? It's working totally fine. Oh wait, maybe when I clicked that, I got some other exa? Oh, because this guy's falling through to there and then getting killed. Or something. Anyway, this looks fine. Okay, we've saved like 2 instructions or something, and we've got the same output, which is great. So now we might have enough instructions to do this BS here. So we're going to copy F to T. Do strings count as true or false if you don't compare them? If the register T equals 0. So we're going to go there. Damn it, we're already too many? You've got to be kidding me. How did I just insert 5 instructions? Actually, since we are zeroing out the right link, except now our seek is the wrong place. We're like 4 instructions over. This is terrible. Yeah. This is terrible. So I believe that this code is very close to working. It's just, oh my God. All right, can we get 4 instructions back from this? I bet we can. This is just our probe sender. We're going to use a Swizz trick to send these probes. Okay. So we launch a probe NX. Because X has the number of the exit that we don't want to go through because it's the way back. So we do the opposite direction. And then Swizz X 103X. So if it's 1, we get 3. If it's -1, we get -3. If it's 3, we get 1. If it's -3, we get -1. We don't exactly care which of 1 or -1 we get. We just want the other direction. So that'll get rid of a bunch of jumps. So then, oh, and we don't. This just spends some extra instructions dinking around. Look at all those that we saved. I hope that actually works. Let me see how the probes go. Looks like all our probes died. Oh, maybe not. Why are they all dying? Link T, REPL new room, link X, okay, nobody went direction 3 from here for some reason. So we're in a new room. We go probe NX, which will go from -1 to 1. Skip that. Okay. That didn't do what I wanted. What? -100. It's 103X, right? There we go. There we go. Okay. We got all our data. Let's just see what our output is. Well, we didn't succeed. What's our output now? We're not getting any outputs. Okay, let's see why. We're not ever getting to our output node at all. We're not ever getting, what? Oh, because we never, this guy's in frickin' local mode. Okay, let's do our local mode. Here. Oh wait, no, report should be in local mode. The problem is just I don't want this guy, whatever. 149 instructions. Bro. Okay, so now we're in global mode. All right. Now our output is screwed up, but that's not too surprising. Okay, output. We never get there again. What? Traverse. We never get there. Wait, what? This is XA? Traverse. And we're trying to write something. Okay, when this is supposed to be the signal to go. When we're about to write this, where is this guy? This guy is still waiting to receive his first thing, which means we never broadcasted anything, which means our mode was wrong. Must mean we never got an MRD because we were in the wrong mode. Damn it. No, local. Yeah, we just kept killing dudes. We never sent any data. I hate it when I mess with things that worked just to get instructions and now they don't work. Oh God, this is supposed to be to M. Not X. Right, because this guy is supposed to stall so that we could see the MRD. Okay, now we've got all our data and we're in Traverse. So we're back in a reasonably sane world. Okay, so this thing that I did though may not work. Okay, we go down the left link. We go down the left link. We go to output. So we seek -4, we're on this. We copy F to T. F jump, no send. It's true, that's good. We copy T to M, that's good. We seek -1. We wipe that. Oh, copy 0 to F, not T, dumbass. All right. Copy F to M. Okay, great. This looks like spam, but it just says we zeroed out this node. So now, when we get here and we want to go back to a parent, we seek -4, we get the parent value, we go back. we output this guy. I guess that's right. How's our output? Well, it's looking good, isn't it? Are we missing one? Oh, our other guy just isn't wiping his file. That's the only reason we're not done. We did that to save an instruction before. Okay, wait, we can get rid of this anyway, right? Yeah. EXAPUNKS. That was so much work. Oh my God, it's slower. It's slower than the array version, but frankly, we're doing a lot of things that may be bad in this one. So we're going to have to revisit it and see if we can optimize the node visitation and all that. What is wrong with my mic settings? Are they too quiet? What's going on? Windows keeps magically changing something behind my back that I don't know what it is. So like my mic will randomly yeah, only being 20 cycles slower than my personal best for the first iteration is pretty good, right? It's not bad. It holds promise. And if you look at these, this one's 1075. But the rest of these guys are nowhere near. The next one is 1024, 1023. There's very few that are over 1,000. Maybe that was true for the other run as well. I don't know. Okay, this feels promising. Starting from here, we can make good progress. I don't remember why I decided we needed an extra slot for root node. Like we totally could reuse that other slot, I think. Oh no, it's because we write it at insertion time. But I think we write it at insertion time after, I don't know. We can revisit this question about whether we need this extra slot really. And if we don't, then we do all this spam of rechanging all these other guys. Maybe I need to mark which ones are relative seeks. All sorts of things got a little slower, like our probe bot may have gotten slower. Maybe not. Let's see if we can reduce this waste loop. Oh yeah, because the robots are slower. 997, okay. That's just arbitrary timing bullcrap. That's just the fact that we're sensitive to the order of our inputs. That's, yeah, that's not great. I mean, it's not bad because maybe we're getting unduly punished. Let's keep reducing the waste loop. See what I'm saying? Stop scrolling me off the frickin' thing. So goofy. All right. So the one that makes us the fastest is to spin here for 12 cycles. Because that just means that we happen to get the inputs in an order that are favorable, which is cheese. It's cheese. We would like to get rid of that eventually. So one of the things that's bad in this current thing for performance is when we recurse up a node, we check the left link again and zero the left link and do all that. And we shouldn't do any of those things. If we stored in the file the parent node relative to our node, then we wouldn't need to seek to the beginning of the file all the time. So here, way back in the first pass, we seek to the beginning because it's helpful. But now it's not. But the problem is we do want a global there, so we want a global here. I don't know. Yeah, it's cheese. It's big stinky cheese. Big stinky cheese. I think we can get a substantial number of cycle improvement out of this. But we have it working, and it is an improvement. It is going faster than our other thing. If I can copy this here, that'll be better for clarity. How about that? Yeah. Okay, and then we can save an instruction there. Because we're putting this in X, but it doesn't matter because it could be T. Oh, no, it can't because of this link. Ugh. Wait. It could be T. So we copy F to T, right? And we F jump, all done. We link T. All right. That'll be slightly shorter. Yeah. But it's also one more on the instruction count, or one less on the instruction count. Okay. So I think we're going to end the stream here, but maybe later tonight when we come back, we will try to trim the fat. Look at all these, look at all this code. That can't be fast with that much code. Jesus. How did it get so complicated? This was supposed to be my simple tree solution. It totally is time to end the stream. What is the top percentile? Okay, we're not in progress anymore. This is the new attitude officially. Wait. I have to end the stream because I have to go to work and do my real job. What is top? Why isn't it not showing me? Is there no top percentile for this? Why are we not getting top percentile? Have less than 1% of players? Have they turned off that option? Why did it go to hide? That's weird. The update must have reset that. Top percentile. 10th. I'm not even in the 10th percentile for this. What? I guess this is the top percentile of everyone who submitted scores. How can my solutions be so bad that I'm not even in the 10th percentile? That's awful. Yeah, I better give up on programming. This is real bad. Look at that. I'm less than 10% above the top 10th percentile in cycles now, so that's good. But I am missing something basic about this puzzle, I would say, that other people are figuring out. I feel like I could change my tree traversal strategy. Because I'm trying to do it in the classic way, like recurse from the root, and I wonder if you can do something like chase as far to the left as possible in a tight loop. Don't ever zero the left nodes. And then you go to the parent. I don't know if that's functionally any different from what I have, except for the non-zeroing of the nodes. I don't know, I need to think about it. Looks far left on the bell curve. Look, far left on the bell curve is not good enough where I come from, okay? This is not acceptable. Look, my smallest solution was way smaller, and we could make that even smaller now that we know some other tricks. So there are people with way more activity. And I wonder if that means that they're doing something crazy during the search phase. So again, we have this thing going on where by the time we still have this synchronized depth first search happening because I'm stupid and I can't figure out how to avoid that. By the time that's done, we're 562 cycles, right? Again, we're already slower than Tyler's entire solution before we even sort the list. Oh, although actually here, we have sorted the list, we just haven't output it. It's outputting it that takes the rest. How long? Okay, so it's 562. And then 944. So just outputting that sorted tree is taking us a long time. But just doing this search, again, is longer than his entire solution. Which either means I could parallelize what I have, which seems hard, or something totally different. Now, the fact that there's all these people with much more activity leads me to think there's some kind of solution with like walking the solutions back and appending them to a file. Maybe you could do a probe flood fill where you attempt to grab a known file number, but like, what if two guys try to grab the file at the same time? I don't know. I need to think about that. Only smart programmers get to the end of the game, so top percentile of the final problem is more like top percentile of the top 10% of players. So 1 in 1,000. 1 in 1,000 is not good enough where I come from. Okay, this is not how we play it. All right. I've thought about how to synchronize these guys with network messages. I haven't figured it out. I don't think there is a way. I'd like to see a revisiting of the game from the start. Yeah, maybe we'll do that. I don't know. I mean, at some point, I've been spending so many hours on this game. At some point, I have to do real work. Um, but yeah. Well, here's the thing. So when it comes to strategies for doing this room data collection, everybody, it's very easy to keep in one register the direction back, right? And that's in fact what we do, sort of. You know, we fill out this space with, let's just jump to the end of the waste loop here. We fill out this space with guys, we're not. We fill out this space with guys that have, you know, one thing per direction, but they're also not doing anything. So like in X, it's probably the case. Yeah, in X, they know which direction they came from and all that. So we leave a guy in each non-leaf room. And right now, we're leaving those there so that some guy can travel around and collect all their information, right? We could instead recursively gather all their information. So, you know, if you detect a nerve, you could walk back and tell that guy, and he would be on a delay loop. He would be in local mode, and he would test MRDs starting like 3 cycles later, and basically put all the data into a file, and then link, and read off his file, and whoever's there would put all his data into a file, and then link, right? Now the problem is, it can't be as simple as this guy tries to send his whole file, because two guys, it'll just get scrambled. So what you have to do is you have to local mode send. You have to REPL something that local mode sends and then exits. You test you don't test MRD because that guy's local mode sending. If nobody's in the room, then you'll just get back his thing. So he sends something. You read what he has to say. If it's your guy, you don't do anything. You just fall back. If it's not your guy, you copy all the stream until you get an end. Then you fall back and you report your file, right? So the problem with that is timing, because if you think about it as just being one room deep, it's very easy for the guy to get the information and come back quickly. But when you're down here, you have to wait a long time. So maybe these guys do send back probes that say, hey, don't exit. We're going to have information for you soon. It's just that's starting to get complicated. But, I mean, it's probably not more complicated than all this. You know what I'm saying? And then you have one guy with a file with all this stuff. I mean, I feel like that's what has to happen. Maybe there's a way to do it even faster than that. If I leave now, what will happen to all my weird symbols? I don't know. What will happen to all my weird symbols? Well, I gotta go work on games. I like working on games and not just playing them. Is there anybody else playing this game? Yes, there's a Japanese dude. He is probably... His microphone is down very low. But he's the only other person playing EXAPUNKS. So we're going to send you over there. Thanks for stopping by. Later on, we'll work on improving this algorithm. Have fun listening to Japanese guy with very low mic. Oh wait, that's not his username?